Hi, Year 7. Sad news, it is our last science lesson together today. I know, I'm upset as well. And we're going to be looking at the reaction of non-metals and oxygen today. Before we start though, first thing we need to do is, do you remember those nails we set up last week? Yeah, to look at the reaction of metals and oxygen. Go get them now. Let's take a look at them. Go on, pause the video, go get them now. Yeah. Okay, now what do they look like? So if you remember, we had 3 nails, okay? And these 3 nails were in different circumstances. This one had water and no oxygen. It looks a little bit larger than the others because of the diffraction of water, diffraction of light through water, which is an amazing physics phenomenon, but I don't have time to go into it this lesson because it's going to be too long if we don't. So no oxygen, oil on top so that we couldn't get any oxygen in, and it hasn't rusted. Nail 2. This had no water on it, it just had air. And I can't see any rust on that one either. Taken a good look before the lesson, couldn't see any. The last one, we had air and water, and as you can probably see from just the water, let's tip it up like this, it's rusted. So we can say from this that we need both air, oxygen, and water to cause rust, to make the oxidation of iron into iron oxide. Fantastic. Okay, so that's the reaction of oxygen with metals, the oxidation of metals. Now we're going to look at the oxidation of non-metals. So you've noticed this around you all the time. If you've been eating an apple and left it on the side for half an hour and come back to it and it's all gone brown and a bit ugh, that's because oxygen has reacted with the apple and turned it brown. Remember how we said change of colour was to do with a chemical reaction? There you go, it's changed colour, it's had a chemical reaction, it's been oxidised. Now this lesson today is slightly dangerous. I'm doing it later at night. I'm doing it after my children are in bed because my little children can't be around this one. It's not safe. If your parents have said, you're not doing this experiment, it's not safe, that's fine. You can watch it on this video. So what we're going to do about today is the fire triangle. What I want you to do is write down the 3 things that you think fire needs to burn. There are 3 things. Pause the video and write it down. And here's the answers. Okay, so the 3 things that we need for a fire. Oxygen. You're probably all aware that the more oxygen you have, the bigger the fire goes. Fuel. We need something to burn. Whether that something is methane or magnesium, as seen in previous videos, we need to burn something. And heat. Now this one may come as a bit of a surprise because doesn't a fire give off heat? Yes, it does. But we need heat to get the fire started. So if you've ever done the whole trying to rub 2 sticks together to make a fire thing, have you done that? Have you succeeded in that? Because rubbing those sticks together causes friction, and friction causes heat. Okay, and it's the heat that gets the fire started because you've got the oxygen, you've got the fuel, you rub them together to get the heat. Okay, so let's look at what this means practically. So we're going to think about how to put out fires. A few easy ways of doing it. If you've got a big fire, you can just spray lots of water on it like a fireman. Yeah? That's taking away the heat. The cold water soaks up all the heat. Not going to go into why and how it does that. That's for GCSE. But the cold water sucks up all the heat and puts the fire out. We can get rid of the fuel. So this is when people say, we'll let the fire burn itself out. We have attended a fire, say the fire brigade, but it was so far gone when we got there, we had to let it burn itself out. We had to let it burn through all the fuels. There was nothing left for the fire, and then the fire went out. And the final one is taking away the oxygen. So if we take away oxygen, the fire will go out. Now this one you might think is a little bit risky, because don't we need oxygen? Yes, we do. So we're going to do this safely. And you've probably seen this being done before as well. But okay, so my practical equipment. Let's bring it all so it's in front of me and I can explain it a bit better. Candle, okay? This is what's going to burn. Wax is going to be our fuel. Wax is a hydrocarbon, which is a molecule which contains both, you've got it, I can hear you, you've got it. It contains both hydrogen and carbon. Well done. Now we have two identical candles, because when we do an experiment, we only want to change one variable at a time. If I changed, I could actually use the same candle for both of them, and I hope you will use the same candle for both of them, but identical candles are what I'm going to use. So we want to take away the oxygen. What's the best way of taking away the oxygen? If I blow them, that's taking the heat away. That's what puts them out. Okay, if I let the candle burn out, that's taking the fuel away. I want to take away the oxygen. Now, some of you will have seen the little putter-outer things, where you've got a little cap that you put over the candle. That works by taking away the oxygen. But you can't actually see that happening. So we are going to use two glass jars. I've got one jar and one vase. We're going to pop it over the top like this. This means that no oxygen, I'm going to have to do this on a larger mat. That means that no oxygen can get in. I am using them on heatproof mats because I don't want my table to get damaged. And we're going to time how long it takes for the candles to go out. So what we need to know are what our variables are. So our variables, what are they? First of all, our independent variable. What are we changing? We're going to change the size of the jar. So we're going to write that down. Our independent variable size of the jar. Okay, so that's what we're changing. We are changing the size of the jar. Ooh, well done. Yes, the size of the jar does mean the amount of oxygen the fire has. Well done. So you can write that for your independent variable. We're changing the amount of oxygen available to the fire. Dependent variable. This is what we're going to measure. So what are we going to measure? Nice one. It's the time it takes for the fire to go out. So it's the time taken for the flame to extinguish in seconds. In science, we always measure time in seconds. Control variables. These are the things you want to keep the same. Now, if I was at school, I would say the same person lighting the candle and putting the jar over it, and the same person doing the timer. Now, either you work with a parent to do this or you do it all on your own. You will also need either the same candle or identical candles. You will need the same air. I know this sounds really daft, but if you do one of them outside and you do one of them inside, or if you do one of them after you've been cooking, so if you do it near the oven, you might have a slightly different amount of oxygen in the air. That's very unlikely. The temperature as well could have an effect, so try and do them at about the same temperature. Lots of different things that you need to keep the same, that you need to control, keep the same, because if you don't, then the results will be invalid. So you will have a table, something like this one here. This one's already been sent to you. Well, I've not filled it all in. So you need to fill in your independent variable here and your dependent variable here. We're going to do more than one attempt. This way we can spot an anomalous result. If we get an anomalous result, we put a little circle around it, we discard the result, and we don't include it in our average. Okay? So, without too much more ado, let's get started. Okay, so I'm actually going to do them one at a time with the same candle because I lit them both and it turns out they have a different size flame. That's not going to be, that's not going to give us valid results. So here we go. I've got my timer, I've got my jar. I'm going to pop the jar over and start the timer. So are we ready? Set, go. And gone. And that took 10 seconds. So I'm going to write down with the small jar, the first attempt was 10 seconds. I've not had to write the units here because they're in the heading. Okay, remember what I said earlier about scientists being lazy and we like to just write down the chemical symbols instead of the whole word? Same here. You put the units in the heading and you don't repeat them in the table. Okay, so reset that, relight my candle, and let's go again. I'm going to give you the full set of results for the simple reason that some of you might not be allowed to do this at home, either because it's using fire, because you don't have the tea lights or the candles, or because you've got small siblings running around and it's not safe. So I'm going to give you a full set of results, just like I did for the nails. Okay, ready? Here we go. Oh, sorry, I started that and stopped it again. So that was 8 seconds. You can, of course, be a bit more precise than me and put it into the decimal places. Last one. Just going to catch some gas with this to make sure it's all nice and fresh. Reset this and off we go. And that was 9 seconds. I would say we don't have an anomalous result. We'll do our average. 10 plus 8 plus 9 is 27. Divide it by 3 gives you 9. Okay, so on average it took 9 seconds for that candle to go out with the small jar. Right, let's do it for the next one. This one's going to take a bit longer, so I'm going to show you the first one, then I'll pause the video and just give you the results. Oh, sorry, I didn't reset my timer. These things happen even to the greatest of scientists. And we would expect this to take longer for the simple reason that the jar is bigger and has more oxygen in it. There was a space for you to make a hypothesis on the worksheet. I'm kind of hoping that you did that even though I didn't prompt you to. It's still going at 29-30 seconds. It's doing really well. Oh, starting to go. Come on. Gone. And that was 41 seconds. 41. Okay, I'm going to pause my video now and you're going to see all the results in just a second. Okay, proper, full-on, genuine results. 41 seconds exactly each time. Maybe I should have used the decimal point. Maybe that would have been better. But it was a nice, easy average to calculate at least. So those are my results. If you couldn't do them, use my results. If you can do this experiment, use your own results. Conclusion, what have you learned? What does this tell you about how to extinguish a fire? Okay, I want to know your thoughts. I don't want to know my thoughts. I've started the conclusion for you. It's a bit of a fill in the blank, but you're welcome to write an extra sentence at the end if you want. Last thing before we go, and that is the general equation. If we're burning a hydrocarbon fuel, it doesn't matter whether that is a candle or whether it's wood or whether it's methane, hydrocarbon and oxygen makes carbon dioxide and water. So that's what we have made today. Okay, Year 7. I hope you've enjoyed this periodic table topic. I know I've enjoyed it, but I hope you've had a bit of fun with it as well. I hope you've been able to do at least one experiment along with me. And it's almost time for the summer holidays now. So I hope you have a really nice, safe, enjoyable summer holiday. And I'm looking forward to seeing you in Year 8 and hopefully teaching you, some of you, a bit more science. Take care. Bye.